Welcome to UPSC Study Academy, empowering aspirants and shaping futures.
Ever wondered how our mobile phones evolved from these bulky bricks to the sleek devices we can't live without today? Join us on a journey back in time to explore the groundbreaking 1G technology. Imagine a world where mobile phones were as large as bricks, where making a call wirelessly was a groundbreaking innovation. Welcome to the era of 1G, the first generation of wireless mobile networks.
What is 1G? 1G, or first-generation, wireless networks were introduced in the early 1980s. These networks were based on analog signals, unlike the digital networks that followed. When you made a call on a 1G network, your voice was transmitted by modulating radio signals to carry sound.
How 1G network works. It consists of 5 main components: base stations, mobile phones, call setup, handoff, and channel allocation. Base stations. Each cell in the 1G network had a base station equipped with a transceiver, which both transmitted and received signals. These stations directly communicated with mobile phones within their cell. Mobile phones, early mobile phones, often nicknamed bricks due to their bulky size, communicated with these base stations using analog signals. They were mainly used for voice calls. Call setup. When you made a call, your phone sent a signal to the nearest base station. The base station then routed the call through the mobile telephone switching office, or MTSO, which managed calls within the network and connected to the public switch telephone network, PSTN. Handoff. As you moved from one cell to another, the network would automatically transfer your call to the new cell's base station. This process, known as handoff or handover, was crucial for maintaining call continuity without dropping the connection. Channel allocation. Channels were dynamically allocated to accommodate active users in each cell. Frequencies were reused in non-adjacent cells, which helped manage the limited spectrum more efficiently.
Key characteristics of 1G networks. Analog signals. 1G networks used analog radio signals for transmitting voice calls. This meant that voice was transmitted as continuous waveforms rather than digital bits. Frequency modulation. FM voice transmission used frequency modulation, where the frequency of the carrier signal varied in proportion to the amplitude of the input signal. Frequency bands. Typically operating in the 800 to 900 MHz range, the specific bands could vary by country. Cellular structure. The network was divided into multiple cells, each served by a base station. This allowed for the reuse of frequencies across the network, increasing capacity and coverage area. As users moved, their calls were handed off from one cell to another. Speed and data transfer. With speeds ranging from 2.4 kbps to 14.4 kbps, 1G networks were sufficient for voice calls but not for data transmission. Voice calls. The primary use of 1G networks was to facilitate wireless voice calls within a country, a significant advancement over landline telephones.
Limitations of 1G. Poor call quality. Calls often had poor quality, with frequent static and dropped connections. Large phones. Mobile phones were large, bulky, and had short battery life. Limited security. Analog signals were easy to intercept, making eavesdropping a common issue.
Impact and legacy. Despite its limitations, 1G was revolutionary. It paved the way for future generations of mobile networks, leading to the development of faster, more reliable, and feature-rich digital networks. The introduction of 1G set the stage for the mobile communication revolution that eventually brought us to the advanced 4G and 5G networks we use today. Coming up next in the technology series, we have 2G, 3G, 4G, and 5G technologies and their working.
Don't forget to like, share, subscribe, and hit the notification bell so you won't miss the next part of our series on communication systems. Thanks for watching.